Okay. So what we're going to do today, I'm going to finish with chapter 1. We covered most of the stuff here. We are about here. And we said, okay, we have a problem. We got the data. If you remember, we got the data from two places. We downloaded it as like an Excel. Then we took the data, we split it to 3 databases. One database, it's everything's. One database we removed like 7 countries, and we have left with 29. So we have 36 countries. So we have 3 databases. One that includes everyone, every country, 36. Then we have 29 countries and 7 countries. Okay? Those other countries are not the one that they are missing. And what we look at now, okay, so let me repeat that. Let me just remind you. And the place we have done everything was here. If you look at the one more time, chapter 1, if you recall, we we use this function. Please do go over it over and over. It's not easy stuff, okay? And here we kind of taking two data frame of pandas. Those are the 2 that we read. We have a nice function in Panda to read those 2 Excel. There are 2 Excel that we read. We transfer them to this function. This function we have written right here. It's this one. We went over that last time. The bottom line of all of that is we have the full country state, but we took those 2 variables, and here we did, okay, like we took all the indexes, we split it to 2 indexes. One index is to keep, which countries to keep and which countries to remove. So this one is the countries that we removed. This one is the country we kept, and this one, all the countries. So since I have a return, it's going to return 3 data frame. Those 3 data frame are right here, those 3. One is the full, one is the sample. Sample, it means the one that don't have the missing one, and some data that is missing, okay? So far, so good. That's what we did last time. Now I have 3 data sets, and then we went to, that's what we do when we create the object. And this one, what we used. Then when we go to the, to the view, and we go and look at chapter 1. Here it's chapter 1. And the first one, this one, that was when we go to the application. Right here, we go to plot the data. I probably would go slow now because it's running on the other. Let me refresh it. So maybe, yeah, maybe I didn't run it. Bear with me, sorry. Yeah, I didn't run the server. Let's go back and run it. Very good. Log in, admin, SQL1 PASS, and going to here, go to chapter 1, and going into plot. Okay, so how did we get this plot? Very simple. In fact, we took the data frame in here. We got those 3. We're using this sample data, And how do I access this sample data? When I'm in the view, I'm building up the algo. And since the algo does all that work, it has this variable. This algo sample data, it really refers to this data set because it says self dot sample data. So this data, after I create the object, it does all the work. I can forget about it. That's done. Now I want to focus on machine learning. Now I want to take this data, I want to make a picture of it. And that's what we do in the view. View chapter 1, the first one. Yeah, what I really want to do is to paint the GDP and life satisfaction. So I create the object. The object already does deal with all the data, organize it for me. And then the algo, it's my object. This is the class. And I'm making a specific, by the way, I can make two of them if I want, as many as I want. So I don't really need as many. One is enough. And this algo has inside this data frame. And data frame in Python has a special function called plot. People have combined make pictures of plotting with the data frame. So this is really convenient. And I tell him, take the data from here. This is data frame. Plot. What do I want you to plot? I want you on the X to put GDP, on the Y to put life satisfaction. There's two variables in the sample data. One of them is GDP per capita, one of them is life satisfaction. So on one axis, I want you on the X, I want you to put GDP, and the other one life satisfaction. And then which kind of a plot I want scattered. We will see there's different kind. I can have a histogram, I can have a bar chart and all those kind of things. And please do look at, if you really want, please do be active. You can write to yourself plot with data frame. I'm just making it up. Honestly, I never looked at for that one. Okay, just do enter, and you can see there's a lot of, documentations. Okay, here is documentation. I'm just see how many kinds you can make: line, bar, horizontal, histogram. There's so many kinds. Okay, scatter. This is the one we just using. You can use a pie. Looks nice. Area. There's a lot of them, and you can really. This is really the all the instruction. But you can go and what I would do, I would even write example. Here we go. Pandas plot example. That could be really good. Visualization. Let's see if this one will be good. Here we go. See, this is so nice. Okay, is show you how you can make plots. So easy. Panda series. Remember we said one column in Panda is a series. Any column, if you take one column, it's a series. So I can take even the prices or whatever, and I can really paint it, by the way. So this is a lot of very nice, by the way, you can make few of them. By the way, this really could be really a nice exercise for you. Try to understand it. Okay? Go over it. Don't be shy. Honestly, I don't remember everything. Even if I want, I can't. No way I can remember. Sometimes even things that I write myself, I forget. I have to go and review it. So, but as many times the beautiful part as I showed you now is to be aware that you can find everything on the internet. Learn how to do one of them. Here we go. You see Panda, data frame. It makes some variables inside df2, and then I tell the df2 make plot a bar type. Bingo, you got it. It has A, B, C, and D. He create them as a random. This one you can understand now, by the way. This is a little hard, but not really that much. What this one does, it says, I want you to generate random numbers. I want you to generate a, I want you to generate basically 10, 10 times 4, 40 numbers, random numbers. And look at that is a two array. You have 10 by 4, 10 rows, 4 columns, and generate random numbers. This is like a special function in NumPy. Remember, NumPy, it's not Panda. And when I put it here, I'm converting it to a Panda data frame because NumPy doesn't have the plotting you have in data frame. So I convert it to a data frame. And when I convert it to data frame, since this is a matrix of 10 by 4, that means I have 4 columns in the matrix. This is a matrix. That's not a table. NumPy is all about matrices. So I have 4 columns, 10 rows, and when I add these one columns, it means give them a name. Every column give A, B, C, and D. So I have, now with this one, I have a table, Panda. And now when I tell him plot bar, he automatically making a bar for each one of them and call them A, B, C in different colors. So it's pretty cool. By the way, if you run it differently, it will generate different numbers. That's pretty cool, by the way. It really is pretty cool. So usually you will need the show command, otherwise you will not show it unless you save it to a file, something I showed you how I did it, and I will show you today again. Okay, but basically all those you can do easily. All the similar. This is very nice for a stochastic process. This is really a nice chart, by the way. And I would recommend that you follow that. By the way, this is the same thing. Do you see that one? Same function. 4 columns, and I ask him 1,000 rows. And then I tell him, but this is very interesting. This is very unique. We'll talk about it later sessions. Says this is a time series. So give me a time series index. View it as a time series. It has a lot of meaning, and especially stock prices. If you do analysis over time, that's very important. But the beautiful thing is, if I have a matrix, here we put a random numbers, but it could be any things to build the matrix. Here, just for convenience, we're putting a random numbers. So, and it says view it as a time series. The index is time series index, and columns. Just make a list. It's making a list of A, B, C, D. That means every column will have A, B, and C. Beautiful. So now that I got that one, diff comes sum, by the way, this is just adding it. What this one does, it takes every variable and it accumulate. It's turning that to accumulations. And then it says, okay, make a figure. By the way, this is just creating a plotting. And this really does the work. It's plotting it, and that's why you're getting this one. Usually you will have to do df dot show, but the plot here inside the df, it's already running the show from within. So we get a nice something like that. By the way, of course, if you didn't have this function, you wouldn't get it accumulated. It's adding up the random variables. This is randoms. But we'll get to that. Don't worry about it. What I really encourage you strongly, yeah, let me tell you what I'm really encouraging you to do. Please do that. Let me go to, I'll get back to you. We had a review of Python. We did it also in Python. You have here a prerequisite. We did intro to Python. And if you notice, we have like a nice editor, which is a very, very simple editor. Now, when you look into a website like that and you want to learn a little bit, by the way, this will not run. I need to add the pandas, but in a second I will. Let's see if he has it on the top here. Yeah, here we go. So he's doing this one, import, but it should give me the pandas. Where's the pandas? Why is it missing? It should give me the panda as well. Let's go to here. And you can play with it, by the way. Put it there. I need really the pandas here as well. I don't know why they didn't put it there. Try to study by yourself. This one just closing all the plots has no meaning really. I'll put it there anyway. Okay. And what I would like is to add pandas. So import pandas. I hope it has it. Is PD. We usually write it's PD. That should work now. Let's go here. And let's just take a very simple example. This is a good one, okay? I take this one. Let's go here and use it. You can practice, study. There's no end to that. Let's just make sure that everything is running. I just gonna do execute so we don't get any error. Yeah, I'm getting error. NumPy is not defined yet. So let's do also import NumPy as NumPy. Okay, we need that as well. Okay, I did got an error, meaning everything's really working. Now, what really does the work, by the way, let me do it this way. I'm going to skip this one so you can appreciate it. I'm going to skip this one. I'm just going to do this one. This is really learning, Python relating to machine learning. But the more you learn, the better it is. So if I do a plot now, he doesn't like me. And my job, yeah, I know he won't like me. I'll show you how you do it later on in our framework. Why he doesn't like us? Yeah, because this is not designed for plotting, really. The hell with it. I'm not going to waste my time on that. Let me do the following, though, so you will believe me. Let's leave the plot. Let's do a print. Okay? More important. Later on, I will show you the image. We'll do it nicer. That's the problem of those editors. They are not really designed for real professional stuff. But say you're getting a data set. You see that? We're getting a data set. This is really a data set. 1,000 numbers, okay? Random numbers. You see some numbers are negative, positive, but it doesn't really go up or down. Like it's really just, but if you look at the same things and you take this one, this is really important. Let me take it this way so you can, okay? If you look at this one, on the other hand, and I will do a print, what this one does, it's accumulation. I'll show you later on in a nice printout, okay? It's gonna point, it pointed to, okay, this is the first one. You see the first number is 005. All those they are random numbers, okay? It's just random, it's a random numbers from normal distribution. So you're getting some numbers, and then if you notice the first number is the same, supposed to be the same, okay? It's supposed to be the same. And let's see, 143. Yeah, very good. If you take the second one is negative. So if you add this one to this one, if you add those two numbers, you get this number, 1.59. So what it does, he adding numbers. That's what this function does, cumulative sum. So this is just another opportunity to learn more and more and more and more. This one is cumulative. And that gives you like the price of something. See, it went down all the time, down, and ended up very low. I run it again, it could be totally different. Okay, so this time the number went up. If you, the more you run it, you get in different numbers. Unfortunately, it's already designed for plotting. So the plotting doesn't really work nicely on this one, unless somebody will show me. But I usually don't use it. It's really good for exercises. So please do. Don't be afraid. You know, you have a lot of beautiful plotting you can do. Other plots, as I said here, you know, this is really nice. You can make it horizontal. This is stuff. This is blocking, you know, on top of each other. Beautiful stuff. Now, when you work on something, don't be afraid. Like, go to this website. Look at, you know, this is very useful in a lot of things. Something that shows you the median. This is like the median, the where is the three quarter, the first quarter, and then it gives you outlier. Anything that will be out there or out here will be outlier, like here. You have a lot of outliers. We'll talk about it as we go along. So, and here you have the code. You can really learn it. Please do. Very, very important. You don't have to remember everything by heart. It's hard to remember. Okay. But if you need something, always remember there is a website probably that shows that. Go there, copy the code, make it, modify it, and use it. Okay? That's what I do. Honestly, I don't remember everything. This is nice charts also. Beautiful stuff. This is the scatter, the easy scattered. You can put different colors. You can put the bigger size. We'll see in a minute. Next, next session we'll talk about chapter 2. We'll talk about this one and how to make bigger. Depends on another variable. Will tell me the all those stuff. This is really nice. Okay, pie chart. This is a beautiful, beautiful. Here we go, plotting tours. You can make that one. A lot of stuff. Very cool. So this is a very good website, by the way, visualization, if you can say. How about maybe I will put this one for you guys, even on the website for the Academy City. Let me edit here. How about I put some plotting here? This is the time series. You have a lot of stuff, beautiful stuff. But pivot table, this is a must know. This is so important. We talked about it last time. I put a link for you guys. Okay. Let me put some, let me open this one. When I use the Zoom, it's always not nice to me for some reason. Introduction. Let me see. Links, introductions. Yeah, no, this should be introductions. Yeah, this is introductions. This one. No. Literature. Literature. No, this one. What's happening here? That was my second. I'll be with you in a second. Okay, that will do. Yeah, now that's the one that I want. This is the one that I want. That will be prerequisite, huh? Machine learning. And this is the one, prerequisite. And I want to have Python. This is the one I want. Good. Now let's open this one and this one. And here we go. Let's add it to here. Yeah, this one will do. And just open that one video, go down. Let me add it to For beginners, this is beautiful Panda data frame. Let me edit here. I will just cancel. Come on, baby. Why doesn't like me? Here we go. I will add another link to this one. So you will have it. In fact, let me call it, I'll give it a different name so it will look nicer. And let's call it something else. The name will be visualization. I think this is excellent exercise for you guys. Visualization with pandas data frame. Fair enough. I think this is good. It will be good for you to have that link. That's a good link for here. So for future references. Okay?
Ça, je vais bien. C'est
So
après le travail, je vais
I
détailler
edited
puis
here to the
plutôt
website, so it would be really
vidéo
nice
aussi
for you
après.
to know you have it here.
Hier,
So in the
j'ai
future, you always know you have a
commencé
link
hier.
here.
J'ai
Visualization is a
commencé
very
hier.
important one. By the way,
J'étais
it's
tout ça. Ça
by
se
the
passe
way,
bien tout doucement. Doucement, j'aurais voulu que je commence mercredi, là, mais il a dit
you
que
don't
c'était pas
like it
possible. Il
bigger,
n'était pas libéré.
make it slightly bigger,
Donc, ils m'ont donné une date. Je suis allé me
maybe
libérer de l'autre côté pour commencer, pour voir comment c'était
70%,
hier.
will look nicer. Okay, this is better. And make this one also 70%. Okay, will be a little wider, will be nicer. Okay, beautiful. So should I change? No, that's one I will leave. Okay. Okay, very good. So this is regarding really to see how it looks like. So in a minute, I will show you how I do this one in a nice, elegant way. Okay, we'll make this one. Okay, we'll make this one as an exercise. So I'll give you a little confidence in how to use the framework. Well, here, okay? So we took the data, and it's already created in chapter 1, Algo 1. Algo 1 has 3 data sets. This is the one that has the 29 countries. I asked him to make me a scattered kind. So this is really basically generating the plot, okay? But the plot is really in the memory. It's already in the memory. And in order to turn it into a to actual picture and save the picture, we're using, this is the name we want to give the file of the picture. And I made a function called save figure. We went over that last time. This is inside the utilities as a function of the algo. And here we go. We have a nice, you can go over that. You see he's putting it in the right place, the image, is giving a name, the extension. And there is, if you really want to go over, you can see that I need to go to the static intro. I have data, and under the data, I have data sets. I have images, and all the images go by the chapter. It will go by this one is already designed with the chapter. It will add the chapter, then it will add the figure name. The figure name, it's nothing but, this is the name. Sorry, chapter 1, no, the views, okay? It's the name that I'm giving it. By the way, look at that one. It's a plot GDP per capita versus such and such. By the way, this is exactly this one. Not delete it. In fact, I can delete it. you will see it will create it automatically, because when I run it, if it doesn't find it, you see the way I designed this function, that is looking for that file. If not, if it doesn't find that picture, is creating it. Okay? You don't really need to waste time. By the way, plot is already come from that library. Where is the plot library? Here we go. It's in the memory. So you don't really have to waste your time. You just need to know that if you want to save a file, you want to save a picture, you just do the plotting like I did, and then just go ahead and use this function, save figure. And that's really what we did here. I give it a name and I'm saving it. And that's it. After it's being saved, I'm showing it to you guys on the file. Okay, so let's go and look at it. This is really, you will see if I run it again. Let me go right here, refresh. And why is that again? Admin SQL1 PASS. Okay, I go into here, go to here, and go to this one, go to the first one. It shows me the picture. And the picture is really recreated again. You will see here in a minute. It should be, yeah, here it is. Okay? It's really just this picture. So all this mechanism is really how to paint and how to combine two tables from Excel, blah, blah, blah. Let's go a little move on. This section 2 is slightly different. The next session I said, okay, I have X and Y. Is there a linear regression I can create? And the answer is yes. In other words, when I choose this one, I'm asking him run linear regression between the X and the Y. Okay? And it's very elegant. Even if I don't know what linear regression is, it will do it for me and I can use it. I just need to learn about the weaknesses of it, the strength of it, and how to do it. So if I go here and click select a linear model, see, it just told me it's run. Let's go and see what it did. Okay, let's see what it did here. Okay, so let's go up. Okay, and let's see everything we did here. Okay, we have the algo file again. We have the algo file again. Here we go. Select a linear model for predictions. So let's see. We have a title. We have algo. Very good. We have a X. We're taking the sample data. Remember, sample data, it's the one that have some missing data. Yeah. So algo sample data is the 29 countries. And just take that variable, the GDP. And that's one we talked about last time, converting it to NumPy array, one-dimension NumPy array. The same things we're doing here. We take this, this is the data frame. We take one column, life satisfaction, we're turning it to a NumPy column. So we have two arrays. And now we want to run a regression. I hope that you already did learn in school, but basically it's like finding a line that runs as close as to all the points. And we will talk about it lengthily next time. In fact, in solving the problem in a different way. Today I will show it this way because you have already algorithm somebody written, but we will learn it in more general, okay, as a minimization problem. We do it in chapter 2. So we have X and Y. I create a model. Pay attention. I prepare the data. I have X and Y, stage number 1. Prepare the data. Stage number 2, I define which kind of model I want to use. I want to use linear regression. There is a library in Python called linear model. It has a lot of function, by the way. I'll talk about another type today. Okay, although this is not my focus. And the key beauty is it has you can create a model of linear regression. So I have a model, so data, model that I want to use, then I tell the process, after you have a model, teach the model. Okay, go ahead, fit. It's a function we will see a lot. Fit means make this model based on the data. You got the data, use the data, fit the model. Fit the model, it means find the best line that fit that data. Okay, beautiful. But see, this is what we call a training stage. We train the model with the data, the model find the best line. Okay, stage number two, the next stage is to predict. Let's say I have another observation, which is not part of the data. I want to see what this model tells me if I had this data. Only one point. Okay, I'm taking this point and I'm plugging it in predict. See that? X new. X new, it's really just one. I'm making it like an array. This is really like an array of 2 dimensions. That's why it's double quotation. Don't get confused. It really is a scalar, really. But I'm telling it's like as if it is 2 dimension, one number. It's a matrix with one number. That's really what it means. Okay? So, and now I asking it to predict the Y, I get the Y, and I get the result. And it's all printed here. It tells me I take that, and the Y becomes to be 4.852. So here I ran all what I showed you here. It's really the process of how to run an algorithm. Stage number 1, I have a data. Stage number 2, I pick the model. Stage number 3, I train it. There's usually after the training, there is another stage, okay? In fact, there is another stage here, which called validation. We will learn it in chapter 2. And then this could be my test file. I'm not doing a test here really, but usually I will have a test. Here, I just take a number and put it in the predict. So that's what it's predicting. By the way, if I knew what really the Y is supposed to be for this country, I can see if my model is good, how far it is from the real one. That's what we learn, it's the testing stage. But for now, it's just really getting a little bit the flavor that see how beautiful Python, it already built a lot of type of model. We will use other models even today. We'll use the polynomial today. And you'll see the difference is not much. So here I didn't really print anything besides just telling you, okay, it's ran, go and look at the printout, and that's what it says here. So that's why we come in here. We just see the results that the Y is equal such and such. Let's move to the next one, which is getting a little more interesting. The next one, okay, how do I make a picture like that? By the way, all those blue ones are the 29 countries. Those ones are totally new countries. So it's nice to learn how to do painting on a canvas. It's very easy. And by the way, if you don't remember, don't kill yourself. You always remember what you call. You can always copy from yourself. Honestly, I myself don't even try to remember everything. So how did the code to make a picture like that? Very easy. I have 1, 2, 3, 4, 5 additional countries, not the one that we deleted. They are totally different countries, okay? And we have the 29 original countries. So how do I print it? By the way, stage number 1, the painting of the 29 countries will be the same. I'm running the algo, so I have the data. This one you're already familiar with. This one, by the way, will make only this one. So let's go step by step. Let me do that. I think that's will be useful. So you can see really every stage here. Let me remove. I will remove. Yeah, I'll remove all of that. Yeah, let me remove this one. Okay. The reason I'm removing, so you can see that the process of adding stuff, this one we already have done. Taking data, plotting it, we said scalar, X is the GDP per capita, this is the life satisfaction. The only things I changed is the proportion. I made it a little wider and less taller. I could have taken it away, it would look like the same as in the other one. So let's just leave it that way. Let's run it again. Run it again, refresh. Let's go back to, let's see this one. He doesn't like me. Why he doesn't like me? Did I make a mistake? I destroyed something? Yeah, I did. He's missing something. I probably deleted something. Yeah. Same black. Yeah, I removed some variables here. Hold a second. That was me. I would copy it. I would just, yeah, do I have that one? Hold a second. That was, shoot. Let me do it again. Sorry about it. It's this one I want to keep. This one I want to remove. Remove. Country, I want to remove this one too. And let's do this color. I think that's what I want to do. Let me see. Delete. And let me see if I have here, I'm using that one there. Yeah, I think I am. Lock. This one is just printing it, so it's not really that crucial. Let me do that. Maybe that would be just fine. Let me try it again. Fresh. It doesn't like me now. It does like me now. Let's try that again. Yeah. No, that's not the one I wanted. Yeah, this is the one I wanted, but I didn't want those red one either. So let me see if I can go and remove those red one. I didn't want it to print. Save. This is fine. Save. Let me remove those ones here. Hold a second. Take all of that out. I'll bring it back. Here, this one I want to keep. This one I want to keep. I want to remove this one, this one, this one, this one, this one, this one, and this one. Okay? Let's see what happened now. Save data. Why save data? Yeah, here it is. So it would try to, okay, let me take this one away. Let's keep it. So that's fine. It should work now, I think. Let's try it again. Refresh. Okay. I still get those images. Why I'm getting those one? I shouldn't get those one. Save two. That's fine. Hold a second. I need to remove those red one. Anybody can see that? Anybody? It shouldn't. I know why. Funny. Because I didn't really delete the file. It's not really printing. This one is not working because the picture is already there. So I need to remove it. Money, happy, color plot. Anybody see it here? Yeah, here it is. Oh, not this one. Money, happy. Let me delete that one. Now that I delete it, will show it. I refresh. We'll do a different picture. No? That's right. It's not the right one. Money, happy, scatter plot. Yeah, this is it. Yep, it took that one away. It's okay. And let me see what else. This is fine. This is fine. This is fine. And this is fine. Let me see. It's taking article. Save. Something. Sample. Yeah, I need to take that one out. That one should make the scattered with the new data. Let's take this one out. That's fine too. And this one I don't need. This one I don't need. That should work now. Let's refresh. Still, I don't want to get those red one. I don't know why I'm getting the red one. I shouldn't, but I forgot to delete this one. Try it again. And let's see again. Refresh. No, it's still there. Why is that? And this is supposed to be the red one. You see that? This is the one that's supposed to make the red one. And for some reason, it doesn't like me. What are the following? Hold a second. Chapter 1, several countries on plot. Why several countries on plot? Let me tell you what I'm going to do. I'm going to delete all of those. All of those, I'm going to delete all of those just in case. And I'm going to see what's happening here. This is very weird. Let me restart it. Go up. And this is should. Let's start a new one. Take it away. And go here. Intro, chapter 1. And let's try that. Now it does give me the whole things, and I have no idea why. It should give me only one picture there. Another one. Yeah, this is it. And why does it do that? I have the algo, I have the title, I have the sample scattered, and this is just fine. Then I have this one, which is okay. I have this one, and it's saving it. And then what makes the picture to include that one? Saved data. That's okay. PNG image. That's weird. Yeah, see, this is only this one. So, you know what I think happening? This is very weird. See, this is the picture it's supposed to show me. Anybody wants to guess why? What do you think, guys? Anybody want to guess why? Why that happened? What do you think? I'm guessing, yeah. I think he's using caching. I'm gonna go a different browser. I have a feeling he's doing caching. So let's go back, chapter 1, and go to here. Yeah, that's fine. I'm gonna go to here, and here we go. By the way, that's a very common problem that many times drive you nuts, like I went crazy now. Here it's the right picture. This is really the picture that is really creating here. Okay? This one. This is really it. That's the one it's supposed to show me. The reason it was showing me, by the way, let me delete all of them. Appreciate it again. You go to this browser, I refresh, I go here and click here. Okay, he's giving me already the right picture, and he's doing the right picture. But what happened, see, this is the right picture. What happened when I was here, let me see if the caching is gone away. Is still remember, is many times remembering the picture, right now going away because he's asking me to do a login. But if you get into this problem, don't think, so your code is fine, our code is fine, but now it might give me the right one. No, it's still giving me a picture is keeping in the memory of the browser. So don't be discouraged. Just, or you go to the history and delete the old ones, or just move. I have two browsers. That's the reason I'm holding two browsers. This one doesn't have the old memory. So that's why I stopped using this one. Just, or you can change the configuration. Anyway, let's move on. What I really would like to show you is, okay, this is what we have. And what happened if I open this one? This one, it's defining more countries. This is the part I'm defining in a dictionary, and the dictionary has countries. You see that? For every country, I give him an X and a Y. Fair enough? Okay? I have X and a Y. And the same things, Australia, United States, this is the X's, and that's the Y. Okay? So this is just definition of a dictionary. Nothing going to happen here. This is just for me, so I can know that everything works fine. And this is the important things. So this is painting the countries on the image. For every country, I'm taking the position text items. This is very important for you to remember. This is the dictionary. You see that? And the dictionary, when I use a function called items, it's really returning two parts. It returns the index. This is called the index. Country in this example, it's the key. You can call it the key. Hungary, Korea, France. This is the key. And this position text, this is what we call a tuple. Remember? That's a tuple, has two numbers. So post text, it's a tuple, and the key is Hungary or Korea with the second one. Let me print it for you so you can appreciate it. Print. And I will do country. And I will add the pause text. So it really is what give me the whole list. You will see that. But the other things is, see what we're doing here. This is also very important for you to know. This is the data frame, the 29 countries. Remember? I'm asking him to look for those countries that are in here, that I marked here, okay? And for every country, give me a X and Y. Don't forget that the sample data, by the way, the lock goes by the index, okay? So it goes by the country, whatever the country is, let's say it's Hungary, is giving me the X and the Y. Now, this is just garbage. This is really could have been replaced. This is just telling you this is also a nice Python writing. Country to be equal to US if the country is the United States. So when it gets to this country, is replacing it to be US. So country equal US if country equal to United States. Otherwise, just keep it, meaning if it's Hungary, Korea, or France, don't change. But if this one, just write country equal to US. Okay, beautiful. Now, last things. This is a little tricky. Don't kill yourself if it doesn't make a lot of sense to you. So don't kill yourself. What do I mean by that? Please pay attention. This one and this one, we are taking from the post X and Y. That's what comes from this data frame. Okay, beautiful. So the X and Y, we're taking it from there. On the other hand, the post text, pay attention. This is really telling me the position I'm going to write the word on the plot. Okay, I will explain that in a second. And then it tells me, make an arrow. Okay, first, honestly, I don't even try to understand how does it work, but let me explain what this one does. Let's run it again. This time, I'm going to go here, rerun it, refresh. No, I have to delete it, otherwise it will not show me to that one. I'm going to delete it. Okay, hopefully it didn't cache it. Let's refresh. Go to here. And here we go. Pay attention. I have the name Hungary, Korea, French, Australia, US. Those red line, they are in the database. Okay? They are in the database. Fair enough? They are in the database. Let me see if I would be lucky to remove it so you can understand what I mean by that. Let me delete this one. Okay? And I'm going to comment this one again. So we see the previous one. Okay? Hopefully it won't cache it. Let's refresh. Okay. Okay. Please look at this round. You see this round? This round. If you see this round. Okay, there's 1, 2, 3, 4. The fourth one down. Look at this one. What's going to happen to this one? Let's go back. And this time I'm opening that one and run it again. I have to delete it, otherwise it will not change the picture. Go again, refresh, go here, refresh, and go back to here. Oh, did you notice it becomes to be red? It's the same point. It's the same point. I took the data from the same table, but I told him put the word Hungary in this place and make an arrow going to here. What does the work? It's this part. So first of all, I'm taking for that specific country. This one, it's a very important for this country. I go and look in the index, okay, for at that country. So when I get to, let's say, Hungary, okay, it's pulling the X and Y. I'm using the X and Y for the picture itself. This is really plotting the dot. It's putting the dot there. In addition, it tells him put in the white the text, write the text based on the position X. What is position X? If you remember, it's really this one. This one, we took it from here. It's right here. And this one is really is those two numbers, 5001. Okay? So that's the way it's printing the text. Which text is printing? It's really the Hungary. It's the country. That's why I give him the country. Annotations, it's plot annotation. It means type for me this country, put the dot in this place, and the text, whatever the country is, if it's Hungary, put it in this location. Very simple. The rest is really just making an arrow. Okay, black, width, can play with it, shrink, blah, blah, blah. Don't waste your time too much on that one. And this one just telling me, when you do that, just put it in arrow. But I wouldn't waste my time trying to figure that one too much. It's just law that exists. If you need this kind of plotting, you know it's there, and then use it. Fair enough? So then right after that, it's really making the image to look nicely like this one. Okay? So now we have just showing you really how you mark some point. Okay? Look at those ones. Those are some countries. They are in the database. Just to show you how you can emphasize a specific point if you do want. Okay? Just for future. Don't try to remember that, honestly. It's not that important. It's important when you need, go back to the code, copy it, change it a little bit until it works. Fair enough? Let's move on to the important stuff. Let's see what the next one. GDP, life, different parameters. Okay. By the way, we have the data. we have this data, and we want to do a line. Which kind of line? I can make a line like this, I can make a line like this, I can make a line like this. Which line would be the best? So that means we have to have some criteria. In here, if I want to make a line, it's, depends. In order to draw this line, for example, I need where I start at, okay? And the Q1, it really is the parameters of the X. In another word, this is the slope. Q1, it's the slope. It's the slope of the curve. It's negative, it means it's going down. Fair enough? It's going down. It really is a very small number. It's 5 times 10 minus. This is like 1 over 100,000. So it's a very small slope. Okay? So this is giving me the slope of the curve, and this is giving me the where it starts from. This one, on the other hand, the theta 0, it starts from a 4, and that's a positive. This is going up. That's a positive. Same thing here. I'm starting from a 0, and this is the slope. All those curves are straight line. Which one should I use? So we will see in future sessions, we're going to use the one in which the line will be as close as possible to all the points. That's what we use linear regression. So I'm going to show you the code a little bit. I'm not going to spend too much time. It doesn't really worth it besides just pointing out, but I do recommend you go over it. Go over it 1, 2, 3 times. And if you need it in the future, just go there and copy the code and play with it, okay? So let's play with it slightly, okay? Let's go back there. So we want to go to this one we did, this one we did. Okay, I think this one, is that right? Twinkling, yeah. Twinkling, this is the next one. By the way, in this one, you will see the first part, we always start with the algo, so we get the data. Then we take the sample, we plot the points, okay? Then we start, this part is really printing the possibility number 1, okay? Fair enough? By the way, if you have a good eye, you see it's 8 minus 5 times x divided by 100,000. Why it's divided by 100,000? Because we kind of multiplying it by 10 to the power of minus 5. So it's like dividing by 100,000. This is basically the code to make this line, for this line. Same code, very similar. You can look at this one, same things. This one just give you to make the second line. This is for this line, for this one. And finally, if you go to this one, it gives you to the third one. Fair enough? But don't kill yourself over it. Just remember, this is really how to make straight lines. Forget about it. In a minute, I will show you what's really important. Okay? Okay, so this is really just to get the first image. This is for the first image. It's really the one in top here. So this is just to illustrate different lines, how to paint the legends, and you can look at the code, and if you need it, just copy it from there. You can even change the size, play with it. It's a good exercise, okay? Now, this is what's important. I want to run a linear regression like we did here. Here we just ran, we got the parameters, but we didn't use it. We just predicted some number. Now, I do want to run the regression, find the slope, find where it starts, and plot it. So let's do it. This one I will spend a little more time. Let's look at that one. And okay. By the way, the reason I have a show here, this is if I want to show in PyCharm the image, but I'm not interested. I'm going to show it in the, I'm going to save it and then I show it in the HTML. Okay. By the way, this is already look familiar. We have a linear model. We're running linear regression. By the way, everybody with me or I'm talking to myself? Hi, everybody. Everybody happy?
Yes, we are
Yes.
here.
Yeah?
Yes.
Okay. Don't worry. Please stop me if you need. Okay? Stop me if you
Okay.
need. Okay? And
Yes.
some of which really there's no solution. You really have to go over that by yourself. I just really directing you to go there. Okay. Now I'm going to do a linear regression. Again, remember I defined the model. This is really like what we called model last time. This time I call it Lean 1. I can call it whatever I want. This one again, we have the data, exactly the same data, just this time I call it X sample, Y sample. Then I feed the model with the data. You see it's repeating itself. After I do feeding, this one shows me, is giving me, by the way, this line is very important. It showed me theta zero it's where the lines start, and T1 it's where it is the slope, okay? So I printed it up for you. So let's look down and let's see the printing. And let me just find where I put it. Let me write it again. That's why I know exactly where it is. Let's run again. I think this one. Yeah. Okay, let's look at the code. Where is the data? Let me just see where I found it. For the country, where's all of those? Let me see. Bear with me a second. I need to, did I print something here? Print. No, I didn't print anything here. I didn't print. But I did print 2 lines, which should give me, yeah, here we go. Here it is, okay? It's right in the bottom here. This one coming from the algo. I should really surprise it by this point, but that's okay. Here it is. So it tells me that the line should start from 4.85, and that's the slope, okay? In another word, it tells me I should make a line starting from 4 point something, no, not this one, sorry, 4.85 with the slope. So I just need to know how to draw it. When I have those 2 parameters, I just need to know how to draw it. That's the easy part, okay? You don't even have to remember it. The most important thing is this line, that I'm defining a model, I'm organizing my data, I'm training the model, and I get the parameters of the model. Now, taking those parameters, I just print it up for myself. And now I'm saying, go and plot, okay? Make me a plot scattered. X going to be the GDP and the life. So those are the dots. This is printing the dots, okay? This line is printing the dots. It's those dots. Only the dots, not the line. Okay, only the dots. Then we're going back, putting the dots. Then I say, okay, met the x-axis. That's for the x from 0 to 60,000. The y is from 0 to 10. Okay, then I'm making spaces for 1,000. X, I'm making a lot of dots. So it will look like a line. Okay, I'm making really 60 dots, in fact, to make a straight line. So I'm getting a lot of x's, okay? And now this is the key point that making the plot. I have the x's, it's like 60 because it goes from 0 to 60,000, jumping by 1,000. That means I have 60 points. I'm plotting the X, the 60 points, and I'm taking T0 like a linear equation. Take the T0, it's where it starts from, because when X is 0, that's going to be T0. It will start from the Y. The Y will be the 4 point, what we got before, the 4.85, okay, plus whatever X times T1, which is the slope. So this is basically printing the line, okay? After it's print the line, now question, I'm using my trick. I know that Algo has the functions to save the file, and I'm telling him save it as a regression linear. There should be this page. If I double click here, you'll see this is exactly the picture. The rest, it's the easy part. It's really just sending it to the HTML and making the HTML printed. This one, if you want, just go into this chapter 1. Let's go and look at that so you can see for yourself. You have chapter 1, and under chapter 1, I should have twinkling. Here we go. This is the HTML. It's already that complex, by the way. Very simple. Very similar code. You can see that those, this is for the first picture, and that's for the second picture. Okay, please notice. You have two images. This is image 1, image 2. And see how simple is the HTML. You just have one time to understand how it does. I put an image. And by the way, I tell him basic static. We talked about it last time. Insert data images, because the pictures are in the images. Chapter 1. It's like going here. You go to, it goes to images. Then chapter 1. That's what it does here. And then you put the name of the file. Okay, this time it was twinkling, and it was a regression linear, and the extension PNG. This is really a variable I'm transferring. That's the whole thing. That's how wide and how high I want to make them. Pay attention that it's really the similar, very similar. The only difference is, what the difference between the two? It's just the name of the image. Here it's figure ID 1, figure ID 2. So it's making two pictures, putting them one on top of it, and I'm making some spaces. This is really just spaces. This is just keeping some spaces here. That's all, very simple. The HTML is so simple, very, very simple. Only first time you just learn how to do it, that's the end of it, okay? So that's really concluding linear regression, but that's not the end of the chapter. Then somebody says, Amos, you know, that's really, we have some problems here, okay? You using, if you look at it, you're using only the 29 countries, okay? We removed 7 countries. Remember, we removed 7 countries? Can you put those back? So let's put them back. Please notice, this is this dot, this one, it's the one we just, the regression we did. We're going to look at the whole things again. But this is the regression we made. But look, the reason you got this line, because you removed those countries, you removed those, the square one, you removed them. And because you removed them, your estimation is not good. Why I'm showing you this example? It's very important that you take the representative data. If you know Norway, Switzerland, Luxembourg, Mexico, Brazil, Chile, I cannot just remove countries. If I remove some countries, you know, then my results or my relationship between GDP per capita to happiness will not be correct. You know, based on this one, it seems like it's stronger relationship. You know, the richer you are happier. But that's not really true. If you if you put back, the reason I removed intentionally countries which are very rich, but the happiness is not really that high. It's not really on this line. They are below. Ignoring them, I'm misstating that relationship. So be very careful. We talked about what happens if we have some missing data. We sometimes want to fill them. If I'm missing the Y, maybe I will use the X and fix it. So removing data, it might be very dangerous. Like in this example, I throw away, in fact, I chose those countries intentionally to make a point. You might, if you're just throwing data and not use the right data, your result will be totally incorrect. Let's put them back. And after we put them back, we get the full data, yeah? Run again the regression, and you will see that you're getting a different regression. You know, there is a relationship between richness and happiness, but not that strong as it looks like by the dot, the dashed one. So missing data is very important. Don't throw away data, okay? Right away. Make sure you get all the data before you do the analysis. That's the message of this picture. How do we do that? Now you should, I'm really repeating myself. It will be easy for you to follow now, a little easier. Those one, how to make those arrows is less crucial, but the idea is the same. The only thing is that now we're using square, so you can make a square, but the idea is the same as we did before. The important thing is I want to run twice regression, and I want to paint it twice. So let's see how we do that. That one should be here. And by the way, you really do have all the results right down here, okay? Let's go down. Okay, we have all the stuff right there. Okay, let's look at that. Let's go over the code. Okay, first of all, we're calling the algo. That's why we're getting all those tables again all the time. We can remove the printing. But then we define all those countries. In fact, those are the countries that we removed. Okay. Again, we have algo sample data. This is the point that the 29 country only. So we put those ones, we plot them, and then we just making the x-axis, and then we just go over all the countries, and we're painting those ones on that. We're painting those points. That means we first of all, we're putting the blue ones, all these dots, and then we're making those dots, we're putting the red ones. That's in here. This is really just putting, by the way, this is very similar to what we did before, putting the points there, okay? And later on, we're running again regression, exactly as we did before, nothing new, exactly the same for the first regression, using only the 29 points. If you see, this is the sample data, has only the 29. So we're running the regression again, something as we did before. We're finding the parameters T0, T1 as we did before. And we making the X to have all the data up to 1,000, up to 110,000. So we have a longer axis, and we're plotting that line. Basically, this one is nothing but running a regression, finding the parameters, and plotting it. In another word, it's really this dashed line. Okay? How do you know that this is dashed? Because it's really a small thing that you can add to the plotting. At the B, if you can see that one, when I plot, I just tell him, make it dash. And that's I leave to you guys. You can, there's so many type and so many type of lines. I'm not going to spend the time on that. The next one, pay attention, is exactly the same. I'm defining another regression. See, pay attention, I'm just giving it a different name, but it's the same object as we did here. The linear one, we define another model of regression, but this time I'm using all the 36 countries and the same variable, all the 36 with the same variable. So I have X and Y full, and I'm training, pay attention, I have that fit. That model that I define linear regression, I'm fitting the data, and after I'm fitting the data, okay, I can pull up again the intercept. It's like what we call it, the theta 0 and the theta 1. This is the constant and this is the slope, okay? This is really those two. It's a slope, by the way, you can see this is right here. This is those two numbers, okay? These are the two numbers for the first regression, for the top regression. For this regression, what I printed here, this is really for the first regression, and this one is for the second regression. Okay, for the second regression, by the way, you can see really that it started upper, it started from the Y upper, and the slope is lower. You see the slope is lower, meaning this line, it start higher and it has a lower slope. This is start lower and have a higher slope. That's really what it means. The rest is really just printing the second one. So after I do that, okay, I just want to plot it. By the way, you can tell that the only difference is I tell him K, it means a complete, or it's a straight line, which is really is the way you define how to plot which kind of a line you have. There's a whole, you can look at online. How do you plot which kind of, if I put a B, like I did here, it will be a dashed line, okay? Pay attention, this command, it's exactly plotting the second regression. It's the same things as plotting here, if you notice. It's exactly the same. The only difference is which kind of a line to put. If I copy this one to here, I should really get the same colors, okay? That's the only things. Okay, after that, I save the picture and I'm plotting. I'm just making the HTML. Again, that's very simple. One should be non-representative. If you go up, you can see there is one called non-representative. Very simple one, which include that image. Okay, so that's really basically another point that we would like to emphasize. Is very important not to have a missing data. If you have them, don't remove them for any reason unless you have a very good reason. They are not really outliers. You can't really say outliers. We'll talk about how you identify what are outliers. Sometimes we want to throw away which bad data or fix it. But in this example, it tells you if you remove data, you might don't get the right answer. Okay, and that's really the lessons from that one. Next, I'm going to move to another topic called overfitting. By the way, so far we always talked about a linear file, linear models. But somebody you might have learned, there's a model called polynomial. It's not a straight line. You see, this is a model, very weird, can tick it around to be close to the point, and here is getting even crazy. It's going really, it's like going up, down, very down, then go up, very up, but it's going through all the points. So it's a very good criteria. It's going through all the points. Might be good. We'll see in chapter 2. We talk about what the criteria is. This is a good model. Well, based on the points, it's very close to all the points. Much better than the straight line. Okay?
Hello.
Yeah, much better than those straight line.
Hello.
Yeah?
I just wanted to ask a question.
Sure.
So regarding the process to get that linear model, we have a missing data and then we pull those sample data and then the full data, do we need to do all those steps, or when you have a database, or you need to feed your model at once?
You're absolutely right. It's a very good question. This is just for illustration purposes. In real life, when you're sampling data, the point is don't forget to sample also for those countries. Don't just sample the other countries that we have in the right. Because if you don't do that, your result might not be good. That's the message. Okay. But sometimes you have a problem. Sometimes you might not be able to get all the data. That's a different problem. But if you really want to make a good study, don't be lazy and just get those countries. Because if you got only the blue countries, you should know your result might not be good. The message is here, if you're doing a real study and you're spending money to collect data, you can't save money by not collecting this data. Because if you don't collect this data, your result might be screwed up. That's the message. Okay?
Okay.
You know, I'm working very, very hard to, many times you will see, this is very good. We'll talk about it, you will see. It's that when you're putting data, you really have to make sure that your data is representative. When we will talk about when we split the data to a training data, validation data, testing data, you really should take the data sometimes not randomly even. It looks like let's take randomly and that will be fine. No, sometimes if you take randomly, the validation data set will not be as the one in the training and not in the testing, and then your results will be totally screwed up. It's a topic I'm going to revisit, okay? Very important topic. For now, the message is, hey, don't be cheap. Collect all the relevant data, because if you don't collect all the relevant data, your results are screwed up. Now we're moving to a different topic. Which model should I use? Linear, polynomial? We learn a lot later on, SVM, random forest, decision tree. How do I choose? Here is another model. I don't really know much about it. I didn't teach you much. The only thing is I tell you it's a polynomial. It's an equation, special one. And it looks really good because it really goes over all the line. Of course, when you look at the last 4 points, you realize this is really screwed up, yeah? Because it's going crazy and down and up. But just to emphasize the point, this is called overfitting. Overfitting is when you try to find a model that very close to all the points in the training data. And what will happen in real life eventually, that when you use to predict in the test data, it will not do good. Okay, because I might, have another point, another country sitting right here. Okay, it's not in the training, it's in the test, it will be right here. The model will predict because it's going like that, down, up, down, up. If I'm in here, it will say it should be really here. I'm negative happiness even. It's definitely not true. It would be a big mistake. So if my test was here, it would not be a good model. That's called a problem of overfitting. We will talk about it a lot in the future. Now, I'm not going to explain how the polynomial work. Besides, just go over the process without really even teaching it. Okay, because that's not the time. We'll get there, don't worry. Just let's go over and over and over stuff we did. We call the algo. So the algo has the data for me. Okay, this time I have the full data and I'm plotting it. Okay, I have the x-axis. There is something here in order to run polynomial. By the way, there's a library called pre-processing, And you can take the data and I tell him which degree. I took even a high degree of 60 just to have it as flexible. You know, the higher you put it, it will be overfitting more. But that's for a different discussion. I don't really care either. Let's ignore this one. Let's ignore this one. And just go to this one. By the way, you have a linear regression model. And this is another concept I'm going to teach next chapter called pipeline. Pipeline, I just called it pipeline regression, but this is really the pipeline. Pipeline, it's like when I want to do several steps, I can organize them together and then train the model. We'll talk about it in chapter 2 more deeply, okay? For now, it's not the point of chapter 1. Chapter 1 is really just getting the idea. So all those ones basically kind of preparing the data, okay? It really is a data preparation. Eventually, all my data is kind of in the pipeline regression. It really doesn't do any algorithm. It's only make stage number 1, number 2, and number 3 is really organized. In fact, this is, sorry, I apologize. This is really defining the model, okay? So this is data processing eventually gets to the model. So pipeline is have two processes of preparing data. I'm not going to go into what does it do exactly. Eventually it's going to run a regression. Fair enough? And we will talk about it more in the future. The bottom line is after I have the pipeline regression, which include data preparation and the linear regression, I can use it just like the model. Okay, what do I mean? Here is the data. I run the pipeline on the data. You see that? That's pretty cool. I feed the pipeline, meaning it's going to do stage number 1, 2, and then feed the model. That's beautiful. We'll talk about it, I promise. For now, it might be a little hard, honestly. Even when I first time learned pipeline and all of that, I totally was lost. So don't worry about it. All what I did different this time, in order to run a polynomial model, I need those two processes, which I'm not going to go over that. Besides that, after I do that, I'm running a linear regression. That's all what it does. So don't worry about it, okay? This one, it's clean. This one we did, like making the X and the Y of the model, and that's just fitting it. Then I am predicting, and then I'm plotting. That's it. And by the way, when I do predicting this time, since it's not a linear regression, I'm not looking for the, you know, the intercept and the slope. It's just really getting a curve. It's giving me a curve. And that's really my model of predictions, okay? And just I'm plotting it, and that's why, and then I'm making a picture. This is why you're getting this crazy, this is really the curve, by the way. That's not the time to go over it. We'll have enough opportunities to go over it. I do recommend try to look at the code. Even if you don't really understand it fully, that's fine. Don't worry about it, okay? The key point of this part is to tell you, be careful when you're choosing a model, because you might use a model that is too good in the training data. Most likely it will not be good in real life, okay? That's the point. How do we do those in programming? We will have a lot of opportunities and we'll use it many and many times, okay? My next point, okay, and with this we will finish for today, is last topic, it's called regularization. What do I mean by that? Wow, this one, it's, by the way, it's really, this is a very important topic, so I didn't want to skip it. But the truth of the matter, I really should have talked about this one and then move to the third one. This is just to emphasize on model selection. We call it model selection. Be careful when you select the model. But the truth of the matter, I would like to jump from this one. We said, be careful, don't Don't miss important data, collect the right data that represent the population. And then I want to jump to another topic. Usually in school, they don't talk about the economists, don't talk about it, finance people, very little, but people for machine learning, very important. In order to avoid, okay, in order to avoid overfitting, okay, we use what is called regularization. If I let the regular, when you run regression as you learn in school with SPSS program or with MATLAB, all those programs, if you don't ask it to do regularizations, it will give you really the blue line. Okay, it will give you the red one. It will give you the red one. Okay, but the truth of the matter, you say you want to put some threshold on how big the parameters could be. Again, I will go over that again in chapter 2. But the objective of this one is so you don't overestimating the parameters. And that will be in model selection within the same type of models. Sometimes I know that my data might be noisy and I want to limit that the slope will not be too big, okay? So I put a constraint on it to be within some element. If the parameters will be too big, I will penalize the algorithm. Everything I have said now doesn't really make any sense to you, I'm sure, because that's totally different than what you studied in statistics. In statistics, we say we're looking for a line that is as close as possible to the point. Now I'm telling you that's not enough. Also, put some limitation on the slope, that the slope will not too big. If the slope is too big, that's usually not a good model. Fair enough? Why does it do? It's real life shown that that's better when you have a noisy data. Okay, and I said machine learning is very different than statistics. We talked about that last time. Draman have asked a very good question on that. In statistics, I need to make assumptions about the distributions of the population of those data. And based on those distribution that I'm assuming, I can tell if the coefficient is good one or not, if it's a real one or is it really not a very good one. In machine learning, I don't really care about the distribution. I haven't talked about the distribution at all. And you will see, somebody will say, well, Amos, you're saying that you want to limit the size of the coefficient, but who said that you're right? And I tell him, you're right too. Maybe I'm not right. And I say, I will run it twice. I will run it without the regularization, meaning putting constraint on the slope, how big the slope can be. And one time I will run it with one with restriction and one without. And how do I choose which one is better? Based on the test I will do on the test sample. Remember, next time we're going to talk, this time we talked only about sample data. Next time we're going to take the data and split it to 3. One for the sample, for the training, one for validation, one for testing. Which one will be best? Is it really the one with restriction regularized or one without it? That's what we decide based on the results in the test, okay? That's really finishing chapter 1, by the way. It's the hardest chapter, although really the hardest is supposed to be chapter 2. It is the hardest one, chapter 2. But since we have learned so many concepts here, it makes it hard. So whoever feel confused, don't. Why?
Okay.
Because everything I have done in chapter 1, I'm going to repeat when I
Okay.
go over.
I have a question.
Sure, in a second, just let me finish the line. I will repeat everything again. Where did I put that chapter? I got lost as usual.
A question, please.
Yeah, go ahead. Go ahead. Go ahead. That's no problem.
I'd like to know how we can find or we can identify the right model to use.
Oh, that's a different question. You're asking, in fact, Amos, you took a model that already somebody else have written. Is that right? You're using linear regression. What was that? Let's find it. Here we go. This is a library for linear models, linear regression. By the way, there is a whole API how to write a model like that if you have your own model. But that's for advanced, not for this course. I might touch on that next semester, okay? For now, believe me, you will do very well if you already use existing one. And the reason I wouldn't spend too much time learning to run your own algorithm for the very important reason we will learn neural network. And in neural network, I will show you how you write it. And when we get to the next semester, I will expose you toward the end to TensorFlow. TensorFlow, you can write many kinds of neural network, and amazingly, they are so good in mimicking almost any models you would think about. So it will be a waste of time to write them. Moreover, and that's for really different, I wish you had the mathematics and if you guys want to learn it without the mathematics, I would be more than happy. That's called deep learning. Deep learning is a level above machine learning. 99%, I would say 95%, you really need machine learning doing excellent job, and you really don't need even to spend or waste your time to write your own algorithm. If you're getting into a place which is you really need your own algorithm and you have a lot of data, then you jump to the field of deep learning, which is an amazing topic. Some of the topics I will mention in this course, like reinforcement, I probably will teach you also a little bit on reinforcement, which usually it is part of deep learning. In deep learning, you usually use very complex neural networks, different kind, recurrent neural network, convolution neural network. Those one are very good replacement instead of you go ahead and write your own function. But if you do want, and in fact, I will mention it a little bit next time, you will see that all those algorithms, you have to follow several functions. When you write your own model, you have to define the fit, well, we did it here, like that. Here we did the pipeline, but the pipeline has a fit. You see the fit? You have to define the function. You have to define the predict function. So when you're building up the model, you're not going to start from scratch. You're inheriting from a model. And when you're inheriting from the model, you just define the specific for your own algorithm, and then everything will work like any other model. You will see when we used for the polynomial, we used linear regression. When we learn a lot other, you will see the process will be similar. So when you're writing your own algorithm, you will have to follow those ones. But that's not for now. If we have time, I will be more than happy to write one with you guys. Are you guys tired, or you would like maybe to, I wanted to do this one to teach you not to be afraid to do this one. What was that? Oh, not this one. Yeah. How about we implement this one? What do you think? You want to try that? How do we add one more? So let's add one. Okay, let's add one. Go over that process and we conclude with this one. Stage number one, to add, I need to go to, just remember where I put it, chapter one. Anybody sees chapter one here? I know this one.
The
I
top.
need it in the template, if I remember, not here. I always forget. Here we go. I think it's here. Chapter 1. Here we go. Let's go to chapter 1 and we add another one. And I just changed the number here, 7. So I will, it's very important, otherwise it will not work. 7. I will call it just random charts. Random charts. I just give it a name here. This is behind, and let's call it random chart. Fair enough. Now this is important. This is what we will see. This is what we will see. But this is very important. What we need to do now is go back to the view and let's put it the last part in the chapter 1. Okay, or chapter 1 we started. Okay, and let's minimize everything. This every click has its own page. So I'm going to add another one. Okay, this is the last one. So I'm going to add another one. Else if page equal to this one, then I want you to do something. Fair enough. Now I like to copy for myself. Whatever I will do, I most likely going to, in fact, maybe I don't even need that one. Maybe I don't even need this one. Okay. I might need it for saving an image. So I might take it. I create it. I will take this one as well. Let's go back, blah, 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 blah. I need the save function. Anybody see the save function here? I will delete a lot of those stuff, don't worry. You know what, let's copy everything. I copy the whole thing and then I will remove the whole thing, don't worry. Okay? Let's see what stuff I need and what stuff I don't really need. Okay? I start with the algo because I'm going to use his functionality. I will call this one title. This one will be in the HTML. Random charts. Example. Fair enough. Then this one, that's this one, that's okay. The plot will be that way. GDP, I don't really care about this one. I don't care about this one. I'm not gonna put that one, okay? And we have a plot. This one I don't care. I don't care about any of those. Delete them. I just need the save function. Here we go. This one I want. And let's give it just a name. Random charts. Okay, I can call it anything I want. And it will go here, it will save it there, and then I will take the figure. Okay, figure is going here. I have the title. Let's take this one and copy it, you know, because somebody have done, I have done already all the work. So why waste my time? Take this one, copy, and paste, and I will call it random charts. And don't forget, I'll just copy it so I won't make a typo mistake. Save it. In a minute, I'm gonna random. Anybody see that?
Random
I'm gonna
chart.
change it if I need to change it. In fact, go over here. All those ones I don't need. All right. We need to put other code there. But that one for now I don't need. Make sure I put this one in the right place. Very good. Okay, let's see if I'm transferring title. I have a title. Figure ID, I don't have a figure ID. I just didn't have the plot. I haven't done the plot yet, okay? Which is the important part. chapter, it's chapter 1, okay? Everything's perfect. So from this part, I'm okay. I don't care. Now, how do I'm going to plot it. So let's go back to this example and let's see what this guy did, okay? And let's see if that will work for us, if we'll be lucky or not. Let's go here. Hope it works. If it's not, what the heck? Next time I'll let you know. I have time series, pandas, randoms. This is fine. Then TS, I'm going to make it cumulative. Then I'm going to plot it. Okay, and cross your finger. Hopefully it works. If it doesn't, it doesn't. Then I will figure it out and let you know next time. Okay, let's see if it works now. Let's start the server again. Good. We should go and when we go here, we should go here, refresh, and we should have another one. You see random charts. This one is because we added it to chapter 1.html. Click on it, and bingo! Beautiful, isn't it?
Okay.
You liked it, didn't you? See how quickly I copied? I'm a good stealer. See, every time you run it. By the way, if you really want, every time you will make the picture, this is a very good exercise. I'm going to show you, and I want you to try it yourself. Okay? I made inside to be efficient because I'm not changing most of the time, don't change the data. It makes a picture, okay? And the picture is putting it here, by the way, it's going to be here. Random chart, you see that? If I delete it and go back here, refresh, and choose that one again, 1 second, and click here, I get a different one. You see that?
Yes.
Because it took random numbers. Now, if I want, without going and deleting all the time, you know, I'm always deleting, don't be afraid. Don't be afraid. What the heck? So you make a mistake. You destroyed everything. Recopy. Don't be afraid. I'm going to go here to the utilities, to the save file. And by the way, if you're afraid, just take the whole function. Don't be afraid. This is be confident. Don't be afraid. You should get confidence. Okay. I'm just, you know, commenting the good one because later on I will put it back. I will change this function slightly. So I don't need to check if it exists. If it exists, I don't really care. Do it anyway. Okay. So this way I don't have to delete it every time. Okay. So I don't have to delete it every time. Let's try that now. Don't be afraid. You know, it's you can't destroy anything. Let's refresh. And now see, every time I go here, I should get a picture. I go again. I should get a different picture. Hey, it doesn't overwrite. Hey, I need to tell him delete it. Should. Do it again. Let's see if I'm right. Hey, he doesn't like me. No, it's the same picture. I want probably I need to tell him to delete it. So let's do it. What the heck? I don't even remember how, but I will remove the file. It's I have written it 100 times, but the easiest is to find it right on the internet. Okay, let's put here, if this one exists, we want to delete it, all right? So how do you find out how to delete a file? Very simple. Delete file, Python. I did it so many times, but I always forget. Here we go, deleting files, very simple. Here we go, how do you delete? Remove, so simple. Operating system, remove, very good. So if the file exists, remove it. So let's put there, go back. Don't be afraid. And if you don't get it right, what the heck? And what I want to put there is the path. So since it exists, go ahead and delete it. And after you delete it, I'm hoping you will put the new one because I'm using a new random. Okay, every time I run it, it's a random. So let's go back. Let's go back to here, refresh. Let's go here. Or is it random? That's different. I hope so. Let's see if I'm right. Do it again. No, it doesn't like me. See, I need to find out why. It should delete it. No, it doesn't like me again. Maybe there's an error there. No. Refresh. It's the same one. Why it doesn't like me? Hold a second. Let's see. Anybody wants to help me? Maybe he doesn't do it. Do I get an error here? No. Let's write here. Print.
Let's remove them.
Delete. File. And let's write this one again. So we can make sure we actually deleting. Let's see if that does it. Okay. And you know what? Let's not print it. Let's not put here anything. This way, we know where the random chart. I'm not expecting to see here the picture. No, cancel. Since I'm not printing, I want him to delete. Let's see if he does the deletions. Maybe I have an error there. Let's go here. Let's refresh. Okay, let's go here. Random chart. I shouldn't get it. He's not deleting. Did you notice? He should have deleted, but it didn't delete. So this one, if my mistake. Now I discovered my mistake. It should be if exist. Okay?
Yes.
Then remove it. That was my mistake. See, that's the way it helped me to find out what was my mistake. Go back again. Go here. Refresh. Go here. Bingo. Empty. Very good. He deleted it. So that part is working now. Since it's working, I can put back the code. Control V. Okay. If it exists, delete it. Okay, so we don't need this one. We don't this one. And this one will save it. Okay. If blah, 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 print. Good. Let's see if it works. Go here, here, go here, refresh. And let's see if it works now. Here we got one. Why it's always the same one? I know why. Stupid me. Now it's really was, I made fun of myself. There is a place in which we define in the algo, there is a seed. Here we go. I'm going to throw this one away. This is what makes the trouble. Random seed. I'm going to take those two away because it always will give me the same number. I will talk about it some other session. It's always giving me the same random because I'm using the same seed. Removing the seed, it will give me a true random numbers. Let's go back again. Let's go back here again. Refresh. Refresh. Let's go here. Okay, that's a different number. You see that? Let's go again. Do it again. Why doesn't do I need to do a refresh? Let's do a refresh again. That's a different one. You see that? Pretty cool. Come on. Be nice. No, here, fresh. Now it would work. Every time I get a different chart. Is that right? That's pretty cool. But there's another lessons. By the way, I mean, people that did this one are not stupid. Okay? This is very important. It's checking randomization, but it's if you keep the seed, that's called keeping the seed in the NumPy random function, you keep the same number of seed, okay? Then if you're doing the same experiment again, it will give you the same random. It was originally random and it's keeping it for you. So this is good for you if you want to make sure you're not making mistake in your algorithm, and that's why you keep it. But eventually in real life, if you want to do bootstrapping, we'll talk about that too, you will remove it like I did now, okay? And then it gives me every time different random numbers. But if I keep the same seed, it will keep the same, it will keep giving me the same random numbers. It will remember it's the same random that you ask in that specific function for that seed 42. If I change it to 43, it will give a different random, but it will always keep the same random on that seed. But that's very important for programming and testing and making sure that everything's works, although you're using in random numbers.
Why
It's
is
counterintuitive. It looks like, well, I'm using random numbers, but I'm getting the same numbers. How come? Okay.
why is there 42?
Well, I just made it up. You could use any number. Which number? You want 43? It doesn't matter. Just keep a number. Keep the same number. I just kept it out because I don't want to change it. It's what I have on my server, but could be, let's test it if you want. You'll get different the first time, but after that, you get always the same things. But let me just make sure I repeat, I bring back the right function. That was for demonstration purposes. What was that function? The save. Everybody see that? Here we go. I'm going to delete this one that we just played with now and put that one back. Okay? You will get the same one now. The same, you will get the same, you know, if I go here and do refresh. First time you get the same one, you get a different one. Okay? And if you repeat, you always get the same one because it's the same. You'll get always the same, even if it's 43. It doesn't make any difference as long as you keep the same number. So that's why you usually put it here in the, when you forget about it. I just put it 42, just that's what you guys have also, and it's what we have in the, anyway. I hope this was instructive also, so you don't get afraid. This is, I would like you guys as an exercise, okay? Please do. Let me send you, you don't have a WhatsApp, which is not good. Let me, what was that? Here. Let me put this one. Visual. By the way, this one you have, I put it in the website, okay? And please do, as an exercise for for Thursday, just do what I did. Do this graph. And if you're brave, just do this one. This is even more cool. It's very similar, okay? And do it. This one, you have a link. I just put it in the Academy City. Let me just see if I can find it. I put it on Academy City, I think. Hold a second. Yeah, let me just, come on. I have too many things open. That's really when I use the Zoom, it's always getting me into trouble.
Do you have any?
I just wanted to show you what the link, so you guys will find it. If you go to, where did I put it? Where did I put it? In chapter, no, the prerequisite, Python, I think in Python, am I right? I think I put it here. And in the, oh, we put it, where did we put it? Anybody see that? Here we go. It's in the recommendations. In this one, if you click here, you come to here, so you can copy the code from here. But please do watch the video and look at how I did it, how I added another, basically I added another, what was that? I just closed it. No, in here, sorry. How I added another one here. Please add another one. That's a good exercise. Remind you what you did in, I will repeat, I will just remind you. I will remind you how I did it, and you can watch the video. We'll upload the video hopefully tomorrow. The way I did it, stage number 1, I went up here in Intro to Machine Learning. Then I had, there's chapter 1, double click. I added this one. This is what I see in the drop down. Don't forget to add the number here. With that 6, put 7 in both of those. Put any name you want, random charts I call that. And chapter 1, leave it as chapter 1. This is stage number 1. Stage number 2, you go to the view. In the view, you just put another part here. Basically, I really copied the whole things from here. I copied the whole things right from here. Again, right to here. All things. I changed the page to be this one. I changed the title. I removed this part, which is really all this garbage that the way we're doing the charts. And I copied the code from that website. That's the code. And then eventually I just put figure, I gave it a different name, just like in here. I just give it a different name. And then I use the same things here, exactly the same. The only thing is I took this file, I copied it under a different name. The truth of the matter, I really didn't have to. I could have put the same name here. It will do the same work. But it's more elegant to keep it this way, just in case I want to change it slightly. Okay? Okay. By the way, if you're really brave enough, you can go here and random charts. How about you make 2 of them? No? Take this one. Let's see who is the brave one. And you can make 2 charts. And the only difference you will need to change, just figure ID and figure 1. And make another one. The second one, make it to be, the second one, make it, this is for the first one. You do this part, you have the figure, and then do another one, okay? And then that one will be figured 1. So I will solve it to some extent. See if you can guys get to it, okay? Why did I put it here? Yeah, here we go. Take this code, by the way. You can take this code. Very simple. You can go here and just make a chart like this. This is really cool. Get your hand dirty. Don't be afraid. Don't be afraid. Okay? Okay. I'm going to reduce this one. See how easy it is? This is the way you steal code when you're smart, when you know what you do. Okay? And I am going here and putting it down. And what else? Beautiful. Now that I have this one, what can I do now? This one, I will save it. And I need a figure 1. So I'm going to take this one. And I copy it to here. And I call it 1. And I call it a random multi chart, whatever it is. Now I need to transfer this one to here. So I will copy this one up to here. And I'll just call this one 1 and this one 1. Then I go back to the chart and everything should work because I just put figure 1 here. I should get 2 figures. That's pretty cool. I'll give it to you as an exercise, okay? Let's see who will figure it out. That will be beautiful. Okay, I'm all ears to hear questions. Good to see you guys.